Okay guys, welcome back to my channel. Today we'll be looking at questions from A-level physics under the topic called motion of connected particles. Okay, motion of connected particles. Now, first things first, we all know what motion is: the change in position of an object or a body. Now, we have cases, we see questions where we have more than one object that is undergoing motion. Now, the motion for all these objects are the same. Okay, so different objects undergoing a specific kind of motion. Now, there are different cases you're going to see questions on this topic. I'm going to treat the cases first before we look at questions. Now, the first case, case 1. Now, in case 1, we have a pulley in which two objects are hanging freely from the pulley. Let's call this object 1, mass 1, and mass 2. Recall, every object has weight, and the weight of every object acts downwards. So for the mass 2, we're going to have m2 times g, because weight equals mg. And then for mass 1, we're going to have m1 times g. Remember, because these objects are attached to this pulley by a rope, this rope will experience a force called tension. Now, if this object is said to be in motion, let's assume it is moving in the downward direction. Now, how do we derive the formula for the acceleration of this body? We're going to do that in this video today. Now, what's the first thing to do? We're going to separate this diagram into two parts. This part and this part. I'm sure you agree that the object 2 is moving downwards while object 1 is moving upward. So for object 1, it is moving upward. Now, for the body to be moving upward, it means the upward force is greater than the downward force. So for object 1, we can say the tension T is greater than the weight, because it's moving upward. Therefore, the tension T is greater than the weight. Now, what do we do in physics when we see an expression like this in motion? It therefore means when you take the difference, you're going to get the resultant force, which is MA. So we'll say the tension T minus M1G must be equal to M1A. Now, let's make T the subject of formula. We're going to say the tension T becomes M1A plus M1G. Okay, equation number 1. Now, moving on, for the second body, you're going to agree that the second body is moving downward, meaning the weight is greater than the tension. So we're going to say for object 2, okay, for object 2, the weight, which is M2G, is greater than the tension. Now, what are we going to do from here? Remember, the same thing again, subtract the forces to get the resultant force. So we're now going to say M2G minus tension becomes M2A. Let's make the tension the subject of formula. We're going to have tension becoming M2G minus M2A, equation number 2. Now, we have equation number 1 and equation number 2. We're going to solve them simultaneously. Now, what do we do from there? Okay, since they are both tensions, we can equate them together. So we can say from equation 1, M1A plus M1G equals M2G minus M2A. Remember, we are trying to get a formula for the acceleration of these two bodies moving downward now. So let's solve to make A the subject of formula. We're going to bring M2A this way and take M1G that way. We're going to have M1A plus M2A equals M2G minus M1G. Now what is common here? A. Bring out A and open a bracket to have M1 plus M2. What's common here? G. So we'll say M2 minus M1 all in bracket G. Remember, we need A. We're dividing both sides by M1 plus M2, same as here, M1 plus M2. So this can take out this, right? We then say A. We then say from this part, we say A becomes equal to M2 minus M1 all into G divided by M1 plus M2. This becomes the formula for the acceleration in case 1. Okay, so you just need to know the masses of the objects and the acceleration due to gravity. Remember, M2 is the mass pulling the body downward, while M1 is the mass going upward. So this formula is for acceleration. How do you find tension? Once you've gotten your A, you can put the value of A into either equation 1 or equation 2 to find tension. Many a times, the questions might also require you to find the force in this system. Now, the force in this system will just be, from the diagram, the tensions are both acting upward. So we can say in vectors, when two are acting in the same direction, you add. So we're going to be adding tension plus tension. That gives us two tensions, right? So we're going to have F equals 2T. So the force in this case 1 is gotten by doing 2 times the tension. So this will be all for this first case. We're going to see a question here and then move on to case 2. Now, which question do we have for this case? Okay, question number 1. Question number 1. Don't forget, from our previous derivation, we got these formulas out. The acceleration, the force, and you can find the tension from equation 2. Now, we have a question on the board. Two bodies of masses 5 kg and 3 kg are connected over a pulley with a light inextensible string. We are asked to find the acceleration of these bodies if it is moving downwards. Now this is just like case 1. Therefore, finding the acceleration will just be, remember, M2 minus M1 into G all over M1 plus M2. What is M2? Is M2 5 or 3? M2 is 5. Why? It is the mass in which it's taking the object downward. So we're going to say 5 minus 3. Remember, G is usually 10 or 9.8. But we're going to use 10 to make our calculations easier. Now, all divided by, at the bottom, we are adding the values. We're going to have 5 plus 3. You can say 3 plus 5. It doesn't matter. A plus B, B plus A are the same. But we can't say the same for minus, because addition is commutative while subtraction is not. So we can simplify further to say what's 5 minus 3? That is 2. So we have 2 times 10, all divided by 8. So we have 20 over 8. We can cancel out a bit. 4 into 8 gives you 2. 4 into 20 gives you 5. So we have 5 over 2, which becomes 2.5 meters per second squared. This becomes the acceleration of these two bodies. If we were asked to find the force or the tension in the body we can also continue the tension from equation number 2. M2G minus M2A. M2 is the bigger mass, 5. So we have 5 times 10 minus 5 times A is 2.5. So the tension becomes 50 minus, what will you get here? 5 times 2.5, 5 times 5, 25. That looks like 12.5. Okay, so subtracting these values, this should be around 37.5. 37.5 Newton becomes the tension. 37.5 Newton. Okay, if I got that correctly. Now the force is equal to 2 times the tension. The force is 2 times the tension. You have 2 times 37.5. That should be around 75 Newton. Okay, so the acceleration is 2.5 meters per second squared. The tension is 37.5 Newton, and the force in the system is 75 Newton. This is how we solve questions for case 1. Case 1. Now, mind you, we just solved for a light inextensible string. We did not consider the mass of the pulley, neither the mass of the string, and it was also frictionless. So our next video will talk about case 2 and then get the formulas, also solve the question. We're going to do this until we finish all the cases for connected particles. I hope you learned something today. If you're just joining, please subscribe, like, and share the videos. Thank you very much.